So we're going to talk about Newton's third law of motion. And this slide should look really familiar from the overview as well. And that is Newton's third law says, for every action, there is an equal and opposite reaction. And so forces always come in pairs. And so for a force to occur, another has to push back. And so some examples that we had of this were like catching a ball. You feel the force of the ball in your hand, and then you also exert a force on the ball. Whenever you stub your toe applies a force to the table applies an equal force back on your toe. So in terms of math, this is as simple as it looks. A 550 Newton person is sitting in a chair. What force is the chair pushing back? Well, the force of gravity, so this is the person's weight, so the force of gravity is 550 newtons. That is pushing down on the chair. The chair is pushing back up at the same amount, 550 newtons. So the answer is 550 newtons. You stub your toe on a wall with a force of 20 newtons. What force does the wall hit back? Well, the action force is 20 newtons, so the reaction force would also be 20 newtons. You push on a crate with a force of 70 newtons. What force does the crate push back? Well, if you're pushing at 70 newtons, then the crate will push back at 70 newtons. That's why you can actually feel the crate when you push it. That's why you feel those heavy boxes when you push them. That's why you feel the pain when you stub your toe, is because there are these forces that are pushing back. So then why do objects break if everything is equal and opposite? Well, the equal opposite forces cannot sustain. So for example, let's say a bug on a windshield. The bug exerts the same force on the windshield that the windshield exerts on the bug. But because the bug has such a small mass to it, then it cannot sustain that force, plus force and mass tell you something about acceleration. So since the bug has less mass with the same force would mean a greater acceleration. And you should agree that the bug experiences a much greater acceleration than the windshield does. The windshield basically stays at exactly the same speed, going a constant speed down the road, but that bug goes from sitting still to going very fast in a very short amount of time. And so there's a large acceleration on the bug. For broken chairs, certain chairs only have a certain weight limit, or let's say they get compromised in some way, and so someone who has a little bit more weight to them, there's lots of videos about this on YouTube and everything, right? So someone who has a fair amount of weight sits in a chair. Well, the person's weight is the action force, and the chair pushes back with the same force. But because that chair cannot sustain that force, then the chair experiences an acceleration of that equal opposite force. And that's why the chair collapses, because the chair starts accelerating. Weight limits on elevators. The cables can only sustain a certain amount of weight. And so if you go over that weight limit, then those cables cannot sustain the force of everybody in the elevator, and they can break. So again, the action force would be the weight of all of the people plus the elevator. The reaction would be the cabling holding the elevator up. And if they cannot be sustained, then the cable will experience an acceleration when it breaks, and thus the elevator would drop. So even though the forces are equal, it doesn't mean that nothing moves, and it doesn't mean that nothing accelerates. It's all based on that mass as well. F equals ma. So mass and force tell you something about acceleration.